This is the story of a tornado where the warning system worked, and 158 people died anyway. On the evening of May 22, 2011, the National Weather Service saw the storm coming. Sirens sounded across Joplin, Missouri, roughly 23 minutes before the funnel touched the ground. The warning was not late. The warning was not missing. And yet by nightfall, Joplin had suffered the deadliest single tornado in the United States since modern record-keeping began in 1950. That contradiction is the reason this storm changed science. If you want to understand how one evening rewrote the way America warns people about tornadoes, and how it quietly rebuilt the country's schools and hospitals, subscribe to Changes in Science. Forensic stories like this one are exactly what we do here. Joplin was an ordinary city of about 50,000 people. May 22nd was an ordinary Sunday. Then, in the space of a few minutes, a supercell dropped a multiple vortex tornado that the Weather Service would later rate it EF5, the highest category on the enhanced Fujita scale, with winds estimated above 200 miles per hour. It was wrapped in rain, which meant that for many people, it was nearly invisible until it was almost on top of them. It carved a path close to 22 miles long and roughly 3/4 of a mile wide. It destroyed around 8,000 structures, and it cut directly through the dense residential and commercial heart of the city at dinner hour on a weekend. Here is what makes Joplin different from almost every other famous tornado. The forecast was not the failure. According to the National Weather Service assessment conducted afterward, the warning lead time was comparable to, or better than, the national average, which at the time sat at only about 12 minutes. The meteorologists did their job. The technology did its job. So investigators were left with a far more uncomfortable question. If the warning worked, why did so many people die? The answer they found had almost nothing to do with radar, and almost everything to do with human behavior. Joplin sits in a region where sirens sound frequently, and researchers documented what they called warning habituation. When an alarm goes off often enough, people stop treating it as an emergency. The assessment also found that most residents did not take shelter on the first siren. Instead, they went looking for confirmation. They checked a window, turned on the television, called a neighbor, or waited to actually see the tornado before acting. And on that particular evening, the sirens were activated twice, which several survivors later said created confusion about whether the second alert was real or simply a repeat of the first. So the thing that failed at Joplin was not the science of predicting storms. It was the science of how human beings hear a warning, interpret it, and decide whether to move. That was a branch of science the warning system had barely accounted for. Consider what happened at St. John's Regional Medical Center. The hospital lay directly in the path. Its staff had run tornado drills, and when the sky darkened, they moved quickly, pulling patients and visitors away from the windows. Then the power failed. The storm tore apart an electrical substation and the building housing the emergency generators, and the hospital went completely dark. Ventilators stopped. Glass and debris shot through the corridors as windows and doors blew in. This was a modern, engineered building full of trained professionals who had rehearsed for exactly this moment, and it still could not fully protect the people inside. The damage was so severe that the hospital was never reopened. It had to be replaced entirely. That failure pointed to a second scientific gap, and it set two different institutions in motion. The first was the National Weather Service itself. In its service assessment, the agency made a bold recommendation. It concluded that a warning should do more than announce that a tornado was possible. It should communicate the actual threat to human life in plain and escalating language. Out of that conclusion came a new product called the Impact-Based Warning. Beginning as an experiment in April 2012, Across 5 Weather Service offices in Missouri and Kansas, forecasters started adding threat tags to their warnings. For the most extreme storms, a warning could now carry phrases like particularly dangerous situation or the word catastrophic. The goal was to break through that habituation, to make a person who had heard 100 routine sirens understand that this one was different. That system, born directly from Joplin, is now part of how tornado and severe thunderstorm warnings are issued across the country. The second institution was one you might not expect to find at a tornado site. Within days of the storm, the National Institute of Standards and Technology, the federal agency better known for measurement and building science, sent engineers to Joplin. This was the first time in its history that NIST launched a full technical investigation into a tornado, and it approached the disaster in a way no one had before. It became the first study to examine a single tornado across 4 dimensions at once: the characteristics of the storm itself, the performance of the buildings, the behavior of the people, and the emergency communication that tried to reach them. What the investigators found reframed the entire problem. Of the people who died, NIST determined that roughly 84% were killed by causes associated with building failure. Almost everyone who died was in a structure that was struck by winds at EF3 intensity or higher, and Joplin, like most American cities at the time, had no public tornado shelters. Residents had very limited access to any underground or genuinely tornado-resistant space. When the walls came down, there was often nowhere safe to be. So NIST issued 16 recommendations, and the central one was quietly historic. It called for the development and adoption of nationally accepted standards for designing buildings to actually resist tornadoes. That may sound obvious, but it had never been done. At the time of the Joplin tornado, the model building codes that underpin state and local regulations across the United States did not require buildings to include storm shelters at all. This is where a regional tragedy became a national change. Working with the Federal Emergency Management Agency and the International Code Council, the recommendations began moving into the actual rules that govern construction. Starting in 2015, the Model Building Code began requiring storm shelters in new critical facilities in the most tornado-prone parts of the country. That meant new schools, new emergency operations centers, new fire and police stations. In 2018, the codes expanded further to cover new buildings and additions on existing school campuses. These shelters are held to a demanding standard. Their walls have to withstand a wooden plank fired at 100 miles per hour to simulate flying debris. And the results speak for themselves. Many hundreds of shelters built to this standard have since been struck by tornadoes, and according to NIST, not one has failed. They offer near absolute protection from life-threatening injury, even in an EF5. You can see the change in Joplin itself. The hospital that went dark that night was replaced in 2015 by a new facility, Mercy Hospital Joplin, deliberately built above the minimum code so that it could survive the next storm. Step back and the stakes become clear. The United States, because of its unique geography, experiences more tornadoes and more violent tornadoes than any other country on Earth. More than 1,200 of them form in an average year. Tornadoes have killed more Americans than hurricanes and earthquakes combined. And unlike a hurricane, a tornado gives you almost no time. The average warning is measured in minutes, not days. There is no evacuation. When the moment comes, you rely on the walls around you. That is the lesson Joplin forced the country to confront. The warning that night was not broken. The forecast was not wrong. What was incomplete was the science of how people respond to danger and the science of whether the buildings they run to can actually hold. 158 people died inside a system that, on paper, had done everything right. And it took a disaster of that scale to prove that doing everything right was not yet enough. The tornado that struck Joplin did not just destroy a city. It rewrote the warning, and it rebuilt the walls.